Thank you. Okay. Hello, everybody. My name is Maxim Danilov, and today I want to speak about how we can make our project which built on Django, how we can make this project faster. And before I start, I want to say thank you for my family. Not works. Don't matter. I want to say thank you for my family who support me on all conferences, and thank you to my wife Elena. Thank you to my children Mark and Maya, and thank you to my animals Marcel and Kisa. On the last PyCon, they was with me on the conference. And special thanks to my daughter who created all illustration for my presentation. And yeah, thank you. And who I am? My name is Maxim Danilov. I am developer already 27 years with different languages. 9 years I work hardly with Python and Django. Also 6 years I work with different JavaScript frameworks. I'm also award-winning mentor in engineering. And last 5 years I work in consulting and commercial development, software development with Python. That's why my experience built not only on developer experience, my experience built also on the business experience, how it works and how it not works. All links to slides you can find on the end of my presentation, or you can ask me about it. And all example which I show are tested and you can download it. And probably we can start. Preamble. Performance of different frameworks in Python world. We can see the interesting graph around 5,000 requests per second in one framework and only 500 requests in a second by Django. And mostly frameworks which shows us high performance is not too famous. This statistic I get, you can check on GitHub benchmark, and you can run itself. But I try to believe more on this statistic. This statistic you published on the techempower.com, and this statistic I believe more in this statistic. And again, Django stays somewhere on the end, and Falcon, for example, or Black Sheep stayed on the high performance side. Okay, probably we can believe it, we can skip it, I don't know. But what is about popularity of this framework? And popularity of this framework shows us completely other statistic. Django, Flask or FastAPI much popular, and any other library is completely not popular in development environment. Also by GitHub stars, if you start to collect statistics by GitHub stars, I collected it for 1 month. This statistic shows us also high interest by Flask, FastAPI and Django, and any other frameworks not too popular. Although for me it's really interesting 2 frameworks, Lightstar and Robin, because they offer us some interesting possibility which I cover a little bit later. And which interesting tendency I see in this statistic. The faster framework not popular by developers. Then faster, then less popular. And this is really true. And we have strictly reasons why. If you want to achieve high performance, probably you should choose not popular framework at first. Usage range. If we want apply framework for big field, for different goals, this framework contains many different elements which decrease performance, decrease speed, decrease request responsibility by framework. Also, easiness. Then easy to use framework. Then easy this framework for beginners. Then low performance this framework offers. And why? Because we have multiple checks for errors which can be done by amateurs or juniors. And also very interesting, big community around framework reduce performance of framework. And there is also, we have answer, and once more time, how create Django faster than light? Probably we don't have any solution, but we try. And if we start to speak about performance in our project, which built on Django, the first question which I ask by my teams is how we can improve performance without any line of code. Because it's simply 2 clicks to increase the power of server, or in 2 clicks I can increase volume of memory, and we can simply add caching, we can thinking about resources optimization, how we store our images or any other data. And we don't need to write any line of code. We don't need to write lines of tests. We should not deploy it on the stage and after that on the production. We should not do anything. But I know many teams who completely forget about it or use this possibility only on the put this possibility on the last place. At first, every programmer to improve performance start to code. Oh. And by coding, I have seen many different possibilities how we can improve our performance, or many ideas. At first, we can change language. It means full refactoring of project, and probably we achieve performance. Probably. Or we can use language partially. What it means? We write on Python and somehow we switch on C library to make some calculation and switch back. For example, NumPy, or for example PyDantic. It will be overwritten on Rust. I don't know, something else. Okay. Also, we can change the framework itself. We still in Python field, but somebody think, okay, from Django we should switch on Jappy, Mappy, or something else, and our problem should be solved. Not. We can see it later. Or we can mix framework. Probably one bottleneck in our project, we can rewrite on other framework and it works better. I don't know. The next step which I hear everywhere, is we should change a paradigm of our programming. We should switch from sync to async. But somehow I hear other paradigm. We should switch from async to sync. Or we should switch from functional programming to object-oriented programming. And somehow I hear the voices, no, we should go back to clean functions. Okay, many opinions. Programming is subjective field. And that's why many opinions, and we don't have real solution. And of course, we have also possibility to change algorithms or simply resolve bottlenecks in our code. And this is interesting. Efficiency. If I try to draw efficiency, the change of bottlenecks give us the mostly improvements in our code. And also, it takes not too much costs than, for example, completely rewriting the project on the other language or on the other framework. But but if we speak about Django, let's go through coding, because low code, no code solution I cannot show here. And let's go through all these ideas, how it can be written or done. At first, we have a framework Robin. Framework Robin is a wrapper written on Rust. And after that, from this wrapper, we have a possibility to call Python functions or classes. And right now, I offer you the possibility. I install Robin, I run the Robin application, and after that, I call the view which built on Django. It's a standard class-based template view, and this view is called from Robin. This is right or not, I cannot answer, but the performance in one thread with one worker is around 150 requests per second on teeny machine. Okay, it's interesting, it works. I use Rust. Also, I use there the Rust possibility to render template, because in this framework used mini Jinja template engine for Rust. Okay, it works somehow, and if I can switch to Rust and it gives us not too much performance improvements, probably I can switch simply on other Python framework. I take the light star, which says from every tool we are the faster on whole world, and I use the same approach. I run the light star application, and from light star I call Python function, which in this case, this is a class-based view, template view, and I render this all with Jinja, and we achieve a little bit more requests per second. This is a question, and this is an important question. I use Rust. Everybody knows Rust is too fast, but why? Why? In mix in between Rust and Python, I'm not successful. Okay, because I'm the bad programmer, probably. But other question or other answer is that it's too high for these goals. For example, if I collect many different tasks, I do it one time on Python and send result back to Rust, or in other side, probably in this case, we can handle or live with this overhead. But for short request and answer, it's not works. You can try it yourself. Example in lays in repository. You can download, install, and check it. And you can see also on Reddit the gross discussion about it. Why Rust is too slow with Python. Okay, Lightstar. Lightstar give us a little bit speed improvements, but not too much. But why? And in this case, I cannot answer why Lightstar don't give me high improvements. But the next example which I want to show, this is a switching paradigm in between sync and async. And here I show you one example which for me is a little bit lie. Because if I write async function and I run async function in one thread, in one worker, this performance should be lower than sync code in one thread, in one worker, because we have overhead for async loop organization. And my idea probably wrong, but you can see by Lightstar it's the same. Sync one thread is a little bit more performant than async one thread. Also, this results shows us Sonic, shows us Falcon, but FastAPI or Starlet shows us completely other approach. In one thread, in one worker, we don't do, as a synthetic example, a synthetic test, we don't do any async await function, but performance increase double or twice or in 3 times. I think something is wrong with this test. And this is only example. Don't believe for benchmarks. Check it itself and think every time about examples. But this example, I want only to show if we not too much bind our code with input-output processes, async programming don't help us completely or reduce our performance. And in this case, they can only show what we should improve directly in Django to get results. At first, we can remove middleware completely. For example, with standard middlewares, we have around 70 requests per second, and without any middleware, we have the same function. This function we can call 400 or 500 times more in 1 second. And this is only information. Please to choose middleware which you need for your task. How we can do it? Django offers us different possibility. At first, we can create method decorator from middleware, and we can decorate methods. Second possibility, we can use resource protector, which help us to decorate group of URLs. You can see in my repository improved version of resource protector. Also, we can specify get and post in our URLs by Django. It means if goes get request, we call the one view. If we got a post request, we call other view. By default in Django is not possible. In 2 lines, it's easy to change. Forms. By forms, we have a big problem, and also one problem, we have only 1 minute for my talk. But by forms, this is very really interesting. If I remove init from model form and use model form or normal Django form only for data validation, I can increase the performance of validation in 100 times. And what it means? It means Django form, if you do all right, only 3 times slower than Pydantic, which written on Rust and faster than any other solution. But right now, I take simply Django and I use Django forms like Pydantic models, and it's also really performant. Okay, ORM improvements, and this is the last idea which I want to declare. Probably you hear information about joins and subqueries. I always thought subqueries is too slow and I should use joins. But simple example shows us only with 2 models, only with 1 join, if I organize if I organize query set with subquery, I improve performance in 3 times. You can say, Max, you don't understand how SQL works, but in this case, you can find a document from IBM which will be published, in 2011 year, exactly about declaration why subqueries probably performant or faster than joins. Okay. About serialization, simply switch from JSON to mute JSON or odd JSON. And about templates, we should avoid any template tags and filters. It's completely kill your application and performance. And visual improvements, we can speak about it a little bit later. Okay, summary. Don't believe any benchmarks. Check it yourself. Hardware improvements, faster and often cheaper. Known and resolve bottlenecks. This is a way to improve your code. And the last one, know your framework for fun and for profit. Thank you for your attention. All slides, all code you can download there.
Great. Thank you so much, Maxim. One question from the audience, from Justinas. How do you think benchmarks are being made? Which default framework settings?
Different benchmarks offer us settings which specially organized to show one framework is better than any other. In this case, some settings are not default and a little bit changed to decrease performance. Okay. Probably it's not special, but sorry.
Okay, any other questions from the audience? You can raise a hand as well.
Please.
2. Yeah, go ahead.
You briefly mentioned that for JSON you should use the OR JSON, and I'm not familiar with that. Like, why should you use the default JSON serialization, Why should you use some third party
JSON is also a third party.
Yeah, but like not the built-in Python library for that, but.
In this case, we can use, of course, JSON. But if I want to be performant, I should to search other solution. Of course, or JSON have their own restrictions. For example, for special form of data, they completely not works. In this case, I can use mu.json. They works this special format of data, but it's not too performant, for example. I like or.json. I use it more than 4 years, and in my projects, I have never met any problem, because I know their problem is in or.json.
Okay, thank you so much, Maxim. A big applause to, sorry.
Last question.
We still have 5 minutes, so could you, very fast.
My examples which I shows, probably it's too short to see. I show, of course, async. I use, of course, async Django, but I don't use async render. It's not completely finished or not completely clear how it should be used. But my examples build on the async version.
Okay, thank you. We are running out of time, so thank you so much. Big applause to Maxim.